Alright, so we're doing graphs of y equals log base a of x, where a is greater than 1. Okay, so if we start with, for example, we'll just start with y equals log a to the x. If we rearrange that and we're going to take the log over, so the a becomes the base, we actually have a to the power of y equals x, which looks just like the graph y equals a to the x, but the x and the y have been swapped. So when you graph that, say for example, this is our exponential function, y equals a to the x. Because the log graph, the x and the y have been swapped, it's actually just going to swap all of the x and y values. So every x, y coordinate now becomes yx. So essentially what it means is that you flip or like mirror image the graph about the line y equals x. So it'll look like just like that one, but flipped over. So it'll go this way. If this one crosses at 1, then this one also crosses at 1.
So was that the easier way that you can do it?
No, I'll show you the easier way in a second. Yeah, so, and also what we call this, so this one would be y equals a to the x. That's our exponential function that we started off 15a with. And then this one is y equals log base a to the x of x. So yeah, it's essentially the log function is just the exponential function, but flipped over that line. The y-intercept becomes the x-intercept. If there's an x-intercept, it becomes the y-intercept, so on and so forth.
So they're both getting away from that central line at the exact same rate?
Yeah. It's exact mirror image. That I guess you could call it a line of symmetry, even the green line. Yeah, and so we actually call this log graph here the inverse of this one here. So this one is the inverse of y equals a to the x.
Why do you just enjoy both?
I was just showing that if that one's the exponential, then this one's the mirror image of it. Yeah. Okay, so the way that you find an inverse, much like this suggested, is if you're given an exponential function, like y equals a to the x, all you have to do is swap the x and the y and then rearrange to get it in terms of like y equals yada yada. So for example, if you were given y equals 2 to the x and asked to find the inverse, all you have to do is swap the x and the y and then rearrange so it's y equals something. So, you know, take the 2 over, that becomes log base 2. And that's it. That's the inverse. Right? Similarly, if you're given something like y equals log base 3 of x minus 3, like that, and asked to find the inverse, you swap the x and the y. And then you get rearrange it to get it in terms of like y equals. So take the log over, that becomes 3 to the x. Oh, sorry, that should be a y. Y minus 3. and then just take the 3 over. So y equals 3 to the x plus 3. So that one's pretty straightforward, finding the inverse.
Sure.
Swap the x and y, rearrange. Okay. The way that we graph log functions. So, for example, if we have y equals log base 2 of x minus 2. There's only 3 things that you need to find: the x-intercept, the y-intercept, and the asymptote. Now, the x-intercept is easy. You make y equals 0, same as always. We have 0 equals log base 2 of x minus 2. Rearranging, we get log base 2 over the other side, so 2 to the 0 equals x minus 2. 2 to the 0 is what? 1. Yeah, so x equals 3. Okay, and then to find the y-intercept, we make x equals 0. Same as always. Y equals log base 2 of 0 minus 2, so just negative 2. What would that one be? Yep, so you can take the, 2 to the y equals negative 2. Take the log back over, you're just going to end up with what you had. Is there any way that we can represent this so we can equate the powers?
To the 1.
It'd still be negative 2 though, to the 1. It's not the same as 2. There's a reason why it's not making sense.
Because we did it wrong.
No, we did it right.
Oh, because x to the 0 is the asymptote. What?
No, because what are we looking for?
The y.
The y-intercept?
The x-intercept. Oh, no, yeah. The y-intercept.
What possible reason is this not making sense?
There is no y-intercept.
There's no y-intercept.
The limit does not exist. How is there no y-intercept?
Because we can't find a value for y. Because we've got a 2 and a base of 2 and a base of negative 2. We can't. So there's...
I mean, it goes through the x and it goes through y. Oh, no, it's going to be something like that. So that's got something. It's going to go
there's no y-intercept.
Oh. So is it ever y?
Yeah. Yeah.
I don't know why.
Then next we need to find the asymptote. Now the asymptote is whatever makes the log of 0, because you can't have a log of 0. The reason you can't have a log of 0, if we had log base 2 of 0, right, take the 2 over, you get 0 equals 2 to the x. Is there any possible number for x where you get 0? 2 to the what equals 0? No. So an asymptote is going to be where the bracket is 0. So what would that be?
0.
X equals what in this case? 2. 2 minus 2, yeah. So x equals 2 is the asymptote.
Oh.
Just a question about how there's no y-intercept.
Uh-huh.
It won't always look like that if there's no y-intercept, would it? Like, it wouldn't always be
No.
like...
No, you wouldn't be able to find an answer.
What a weird word,
Asymptote. Yeah, so sketching that, we have x equals 2 asymptote. We've got a x-intercept of 3 and no y-intercept because it comes up like this. You can also double check your answer by choosing values of x, putting them in and seeing what you get.
How do you know how, like, to go?
Well, that's when you would like to be very accurate. That was a rough estimate of where it would lie. But to
marks for that unfit?
Yeah.
If the question said like roughly sketch, then yeah. But if
the question says exactly like
no, there's no question where it's not clear what to do. If you want to be super accurate, I mean, you can just check test numbers. So tests like 6, for example,
I'm enjoying them up.
by putting 6 into the equation. So you'd have y equals log base 2 of 4.
how do you evaluate that?
Good question. How do you evaluate that?
Y equals 2, miss.
Yeah, it does. Yeah. Because you take the 2 over, you get 2 to the y equals 4. 2 to the y equals 2 squared. Therefore, y equals 2. Yeah, so 6, 2.
You're not getting that?
Okay, the trick from here, you can go y equals log base 2 of 2 squared. And at any time where you have log base 2 and that base are the same, so the base and the base are the same, they just cancel each other out and the answer is the power. That's just the trick. And it's because of that reason when you take the 2 over and, you know, base of 2 is just the power. It's just an easier way to get to that point.
Or with any number.
Any number where you have the log base and the exponential base, they're the same. They just cancel out. The answer is the power. Okay.
No, I'm not kidding. Shut up. Yes, I do.
All right. This one. Right. Make y equals 0. Let's find the x-intercept. Y being f of x. You know, they're interchangeable. Right. Take the log over. Give it a 0. Of course, the other way you can do that is if you swap the x and the y, find the inverse, it'll be the exponential function. You should already know how to sketch exponential functions from 15a. You can sketch that first and then flip it over the y equals x line, if you prefer doing it that way. Okay, so we get 1 equals x plus 2. So x equals -1. Yep. Make x equals 0, find the y-intercept. So y equals log 2 of 2. Right, this base and this base are the same, so it's just 1.
Go match, right? What did you go?
The base and the base are the same, so it's just the power. The power of 2 is 1.
Take it over and it's 2 to the y.
It's 2 to the 1, yeah. Yeah, the asymptote. Asymptote. What is it?
Doesn't exist.
Yeah, not just a number. Remember, an asymptote is a line. So you need to write an equation of a line. Yeah, x equals -2.
Oh, right. Because you make it, whatever makes the thing.
Whatever makes this one equals 0, because you can't have log of 0. And x equals -2 makes that equals 0. Okay, sketching that. Y, x. Got x equals -2. Should write an equation of a line. Y equals 1. X equals -1. And, you know, it goes to here, goes to here. Approaches this line. So it wouldn't really go up and then come up. It's got to go this way. Like that.
When you said the x, was it negative? Sorry, what? Oh,
X is -1, Y is +1. That's the x-axis. That's the y-axis.
so how do you? So you draw it. So you just draw it as close to. So you draw basically on the line.
Approaching the asymptote, but never touching or crossing.
So is that like 4 marks? Right there.
Sure, why not?
Okay, good. So no, because you. Are there going to be questions like this in the test?
Nah.
Why not? Just the one on the test, miss. Use that one on the test.
Let's just do one.
Give us one on the
It'll take less time to do the next question.
No, don't look at the book, miss. Yeah.
2 to the x minus 3.
Yeah, so
Yeah. No, it's that one's y equals -3. This one will go through
Is it that simple, miss?
-2, right? 2 to 0 is 1 minus 3.
Let's see all the working out.
Yeah. X-intercept is what? Yeah, let's use 4.
Oh no, I've just written it down. Oh man, you can't say one number. Just put a breakdown next to
It'll just make the working out heaps easier. Okay, this is 4 now. Okay, so the that one's different, that one's different. Okay, so that's at -4. Our y-intercept will now be at 1 minus 4, which is -3. Our x-intercept will be at 4 equals 2 to the x, so x is 2. Stefan, as always, we just make y equals 0 to find the x-intercept. We make x equals 0 to find the y-intercept. That's all I'm doing. But however, I have not yet reached the point where we ask you the question. I'm building the question still. Okay? Right. Have I done this correctly?
2 to 2? Yes.
Is it that way? Goes that way?
Must be.
Oh, that was my next question, miss.
Yeah,
That's the line. Okay, cool. I probably haven't given myself enough space to do this, but that's okay. All right. The question is to find the inverse of this function here and sketch it and find the x-intercepts, y-intercepts, the asymptotes, if there are any.
Yeah.
There might not be any.
I mean, is to find x and y intercepts, you can just flip those.
Yes. Yeah.
No?
Depends.
Oh, this is no, so the y-intercept becomes 2. The y-intercept will come negative. X-intercept becomes -3. Yeah, why not him?
Yeah.
So
Yeah.
Is it wrong?
Yeah. Well, first you need to find the inverse. You need to find the actual equation of the inverse. So to find the inverse, we swap the x and the y. So x equals 2. Good 2. 2 to the y minus 4. We take that one over. We get x plus 4 equals 2 to the y. And then take log base 2 over.
Yes. Asymptote is -4.
Good. Asymptote is now -4.
This goes back up what? Alright. You just make when it equals 0.
Basically, you just like this one's -4, so now this one's -4.
How do you know if the asymptote's on the y or the x?
Because this one was on the y and now it's on the
How
x.
did you know it was on the y?
Because that's the question. In the question, you're given that graph.
It changes, mate. It's a thing. No, but
The question starts with this graph and this function, and it says find the inverse and sketch it on the same graph.
no, that's not what I'm asking.
In the first equation, y equals 2vx minus 4.
Yeah.
How did you know the asymptote was on the y, not the x? Because it's y. So it was on the inverse, it's a y.
Because usually in a exponential function, it's an asymptote on the x-axis, and because it's -4, you just move it down 4 spaces. Does that answer it?
Sure, why not?
Wait.
No, because x.
So let's put those in. So -3 and 2. And we also know that it's flipped over this line here. I haven't drawn this super accurately, so I don't know if it's going to work. Right, and then, so ideally it should hit here, and yeah, this is not accurate. It's supposed to hit where the y equals x line crosses that line, but because I haven't drawn it very nicely, let's just pretend that the green line goes through there. This is a disaster.
I didn't get what you did there. It's like,
Your lines should cross over on the y equals x line. So where this black line hits the green line, that's where the two lines should cross over. But I haven't drawn mine to scale or anything, so that's why mine's a bit dodgy. So essentially, right, this one approaches the asymptote, goes through there, crosses that one. Oh, it looks pretty good. Is this the same line but flipped over the y equals x line? This is y equals x.
I don't know how to draw this.
This one is that one. This one is that one.
That's one that's similar to the test.
Yeah.
Sure, check.